Hello students, I hope you're doing well today. We want to talk a little bit about the anatomy of a sine wave. And a sinusoidal wave, or what we just routinely call a sine wave, is going to be where we have a waveform that peaks at the top and peaks at the bottom. Normally when we're doing about this and talking about theoretical processes, we are simply talking about where the sine wave starts and where it ends. We usually draw a zero line indicating 0 volts. And a full sine wave is a moving electromagnetic wave. And these are usually symmetrical, so the peak of this wave and the positive and the peak of the bottom are equal value. So if I have 1 volt, voltage peak is 1 volt and voltage peak negative is 1 volt, then it would be 2 volts peak to peak. So 1 volt positive, 1 volt negative, overall voltage peak to peak. So this would just be a brief anatomy of a sine wave. So you can see over to the left I have 0, and from 0 to t to the right you have that's a full cycle. A cycle is one cycle is what is the time it takes to complete one single wave. And so from 0 to t in this diagram, underneath the white curve here, is a full wave, or a full cycle, if we'll call it that way. So as you can see here, we have several different things to look at, and I'm just going to look at the very top signage here. We have maximum value, and that's the positive peak. If I look below there and just to the right, I see a negative peak. Those peaks are symmetrical, which means the top and the bottom are the equal values. And my 0 over here to the left, you see 0 right there, is sort of the reference point. And voltage peak to peak is going to be across the whole thing. So the peak to peak value over here on the right says peak to peak value. If you look at those arrows, they're indicating that it goes from the top to the bottom. So we'll get more into this when we're actually in lab and doing some of the math that goes along with this. I just wanted to look at and talk about voltage peak is 1/2 of the wave. Voltage peak to peak is the whole wave. And then we have this effective voltage here. And effective voltage, if we want to compute that, that's going to be 70.7% or 0.707. So that sort of becomes my multiplier. So if I have 1 volt peak, then my effective voltage is 0.707 volts. The effective value here is basically the value of the wave that's useful, that we can use. So it's 70% of that wave. I hardly will use this term effective value. The term I use is called voltage RMS. And RMS is a mathematical computation, means root mean square. We won't be going into this computation or the math in there, but voltage RMS is, if I were to take my digital multimeter and I were to measure the voltage across whatever component, or maybe outside of an AC electrical voltage, the voltage RMS value would be what I would read with a digital multimeter. In other words, it's going to be 70% of 1/2 of a sine wave, or voltage peak. And then the voltage average is also 0.637. In our class, we're primarily worried about, on the oscope, we'll read voltage peak to peak, or voltage peak. And that's voltage we actually see on the oscope, or we'll actually read the voltage coming out of the digital multimeter, and that's going to be voltage peak times 0.707 for the voltage value there. So this is just a quick overview to look at the sine wave. So this is sort of just an introduction to it. We'll spend some more time when we're together in class and can answer any of your questions. So I hope this is helpful, and we look forward to seeing you soon.